Welcome to this course on computational mathematics with CS Math. I am Dr. Ajit Kumar, a faculty in the Department of Mathematics, Institute of Chemical Technology, Mumbai. This course will focus on exploring and visualizing important concepts in calculus, applied linear algebra, and numerical methods using CS Math. CS Math is a free and open source computer algebra system similar to Mathematica, MATLAB, Maple, Magma, etc. The native language of C's Math is Python, which is a high-level, versatile, and easy to use object-oriented programming language which is becoming extremely popular among scientific community, among data scientists, and also among systems and web developers. The course will begin with a brief introduction to basics of Python programming, which will enable the students to use CS Math not just as a black box, but as a means to develop programs on their own to solve mathematical problems. Exploring CS Math to its fullest potential will be easy once we develop Python programming skills. The second part of the course will focus on using CS Math to explore, experiment, and visualize some of the important concepts in calculus, including multivariable calculus, applied linear algebra, and numerical methods, along with numerous examples and applications. This course will be useful not only for mathematics students, but for students from other fields who wish to learn applications of mathematics. After going through this course, students can very easily explore concepts in specialized branches of mathematics such as abstract algebra, computational number theory, cryptography, graph theory, optimization techniques, even differential geometry, just to name a few. Not only is CS Math an easy to learn and use mathematical software, it is also very powerful tool that deals with numerical computations, symbolic manipulations, visualizations, and solves complex mathematical problems with ease. Let me explain how simple CS Math is with a few examples. So suppose we define a number n which is 1587. Now anything that you want to know about n, any method that you want to apply on n can be obtained by using n dot and then press tab. You can see that all the methods will appear and whichever is suitable to you, you can choose. Suppose we want to find whether this number is prime or not. I can say n dot is underscore prime, and in order to execute this, you press shift and enter. So this number is not a prime. In case this number is not a prime, we can find out what are its factors using n dot factors. So in case we are looking for a prime number just near about this n, then we can use n dot next prime and we'll get a next prime number. If I want to find out the previous prime number, we can use n dot previous prime, we'll get previous prime number. If you want to find factorial of, for example, this number which was 1587, then we can also find it using factorial function. So it has, you can see that it has many digits, it has several digits. Suppose we want to find out how many digits are there, again you can obtain using f dot n digits. So it has 4393 digits. In fact, you can count how many zeros are there in n factorial, and this is how you do it. So there are about 816 zeros in this. So this command, what it does, it converts this number into list of digits, and then you can count 0 in that list. Suppose you have a function fx equal to x into e to the power minus 1 upon x square plus 1, into sine 2x, and we want to explore this function. So first you define this function fx equal to this, and then again anything that you want to find out about this number, about this function, you can obtain by f dot tab. So if I press f dot and then tab, then all the methods will appear in this drop down menu. So you can choose whatever is suitable to you. For example, if I want to plot graph of this function, there is a simple way of doing. You can simply say f dot plot and mention the domain in which you want to plot. So this is the graph of this function. The figure size is 4, just to make sure that it fits properly in the screen. Now suppose we want to find the limit of this function. There is a option called f dot limit. So if it is finding limit at x equal to 1. You can find derivative of the function using f dot diff. If I want to find third derivative of this function, we can simply say f dot diff, and in the bracket you put 3. Now you can also find Taylor series expansion of f about x equal to 1 of degree 5 using this command. As you can see from the graph, this function has local maximum between 0 and 2. So we can find out local maximum using a function called f dot find underscore local underscore maximum. So this gives you maximum at the point 1.06086, and the maximum value is 0.5660, and so on. Suppose you have a matrix A, 3 by 3 matrix, and we want to explore this matrix. So we can first define the A as a matrix using a matrix function. You have to give list of rows in square brackets separated by comma, and then again you can use f dot tab. You will get a dot tab, and you will get all the options that you can apply on A, or all the methods that can be applied on A. So in particular, you do not need to remember all the commands. Dot tab will give you all these things. Suppose we want to find determinant of a matrix A, you can simply say A dot determinant. If you want to find inverse of this matrix A, you can say A dot inverse. If you want to find rank of this matrix, you can find A dot rank. You can find eigenvalues, eigenvectors. Using A dot eigenvalues, you will get eigenvalues of this matrix. So all these things will be very easy to explore using Sage Math. So I'm actually very excited to offer this course, and I'm sure all of you will enjoy this. I'm hoping to see all of you. Thank you very much.